All right, good morning, everybody. It is 2024, and we are here with perhaps um, one of the most interesting topics, at least that I've been following over the last couple of years. And we're joined today by Dr. Scott Youngquist. Scott, in my opinion, is one of the brightest minds in EMS in this country. He hails from Salt Lake. You can see he's a professor at the Department of Emergency Medicine at the University of Utah. He's also the medical director of the Salt Lake City Fire Department. Scott has been doing some really interesting work. He's done incredible work on, out of hospital cardiac arrest, and he's been on the show before. But when I saw the work he was doing with respect to epinephrine, and particularly getting on epi early, I asked him to come onto the webinar. Probably what, Scott, in 2021, probably it was, maybe a couple years ago.
Yeah,
When you
it
first
was
came on.
2021. Yeah.
And then I happened to see that you presented your abstract data at the AHA conference recently. So I called Scott back up. I said, Scott, can you come back and give us more data? So I put this on Twitter. And then, boy, I had like 18,000 views of my tweet overnight. So there are a lot of people here who want to hear what Scott has to say, and so do I. So without any further ado, Scott Youngquist, thanks for joining us, and appreciate you coming back on the show.
Great to be with you all. Thanks for the introduction. I have huge respect for Dr. Antevi and all he's done to push the science forward for pre-hospital care. And so he's one of the few people I'd be willing to come on and talk about this data. And I hope it's, I won't spend a ton of time on these slides because I want some time for discussion, debate, critique, all of that stuff. I welcome it. And let me go through these slides and then we'll open up for questions. So you guys know the scope of this problem. Most patients die from cardiac arrest. And so it'd be nice if there was something to improve survival. If there was a novel drug, a novel approach, and the existing status quo hasn't worked well. I don't think we'll get to 100% survival ever because a lot of patients resuscitated from cardiac arrest are in the natural dying process, and we just try to interrupt that. They've got severe comorbidities and they're end stage this or that organ failure. But I think we can do better. We can probably do better with what we have. So epi, this is a non-controversial statement, I think, based on the largest and best run trial so far, and that epi improves survival to hospital discharge. But along with that, you get a lot of survivors with brain injury. And you can see the survival, when you compare it to placebo, survival to hospital admission is much higher with epinephrine. And then you lose some patients along the way until that difference between placebo and epinephrine narrows in the Paramedic 2 trial. Now, Paramedic 2 was a great trial. They follow the ILCOR guidelines, which prefer intravenous epinephrine over intraosseous epinephrine. So attempts were protocolized first to get intravenous access, and if those failed, they resorted to intraosseous. So it may be a little different than a lot of US agencies where the majority of cases are intraosseous medication administration. In this case, they attempted IV and were successful in the majority of cases. It was like 1/3 that were IO and the rest were IV. But this also led to delays in the administration of epinephrine. And there is, throughout the epidemiologic literature, a time-dependent effect of epinephrine. In other words, earlier is better. Earlier leads to a shorter low flow time, which is just a continuation of the ischemic time, and earlier return of spontaneous circulation. And in this meta-analysis, when you give epinephrine within 10 minutes of scene arrival, the odds ratio for survival is 1.62 compared to after 10 minutes from scene arrival. So getting that first dose on gives us our best chance of getting ROSC early. And this is a pretty consistent observational finding. And it also improves neurologic outcome to get it on early versus late. In the Paramedic 2 trial, the time from 911 call to the first dose of epinephrine was 21.5 minutes. And I think that's probably a decent time to epinephrine in a trial in which paramedics are, incentivized to get the drug agent on board in a trial and to do a good job. So it's, there's an observation effect there. It's probably even longer in other settings where there's less of an organized approach to the resuscitation, but I don't know that for sure. But anyway, 21.5 minutes is a pretty long time from 911 call to administration. When you look at the routes of administration available, what we do is tibial IO, humeral IO, or peripheral IV. And I would say humeral IO is the less common administration route. But you can look; these also all have pros and cons. Tibial IO, very successful. It's got a low displacement rate, so the overall success is 91%, and the time is short, 4.6 minutes. Humeral IO takes longer, is ultimately less successful, probably because of displacement. So in studies, the overall success was 51%, and peripheral IV is much less successful. The overall success rate, 43%, and time to initial success in this is somewhere between, in these studies, between IO and IV. So the big speed bump to giving the medication is the vascular access. And this becomes more difficult with patients who are more obese body habitus, with pediatric, very small children. I know Peter has advocated for a more reliable approach to intraosseous administration of drug in pediatrics in the distal femur, which is much more successful than the tibial IO. And when you look at pediatrics, the misplacement rate of tibial IO is very high. A lot of this is not where it's supposed to be. And so we don't know if the kid's getting any drug or not from those misplaced IOs. Anyway, so this creates a little bit of a difficulty in administering epinephrine early. And the ILCOR guidelines recommend administering it as early as feasible when initial shocks have failed, or as soon as possible in a patient that has a non-shockable rhythm. We've long used epinephrine through the intramuscular route for anaphylaxis, and we've put this in the hands of BLS providers and even civilians with auto-injectors. And in the lateral thigh has a very rapid uptake in patients with a pulse. There are some animal studies suggesting that it is also absorbed through an intramuscular route, even during the low flow state of CPR. We are doing some of that work. We're analyzing our data right now, but it looks good in terms of, there is uptake even from the lower limb of a pig during CPR and the low flow state of CPR. And we'll report that data once we've finished analyzing it. But the preliminary data supports this, that IM epinephrine does get absorbed. It does have does have its pressor effects when administered intramuscularly, at least in the laboratory setting. So in 2019, we established a protocol change. This was late 2019, right at the beginning of the pandemic, when we were hearing about the pandemic starting in Wuhan, China. And we implemented this feasibility study of an initial dose of 5 milligrams of intramuscular epinephrine in the in lateral thigh in patients in cardiac arrest that met criteria for epinephrine, while attempts at vascular access were made. For us, the majority of epinephrine is also administered through the intraosseous route. We do give paramedics the ability to attempt intravenous if they feel like they can get access. So it's kind of a dealer's choice approach. We don't say, thou shalt do IO on everyone, thou shalt do IV. We say, look at the patient. If you feel confident you can get an IV, go for it. And if that fails, switch to IO. If you look at the patient and there's no way you feel like you're going to get something, then just go straight to IO. Whatever gets you there first is how we've done it. And there are pros and cons to that approach, but that's been ours. So this isn't to replace all subsequent dosing of epinephrine, because I don't know, and when we started this, how much effect this might have on how much pressor effect, whether there was absorption, those sort of things was an open-ended question. But so everything else was the same. We're going to give standard dosing epinephrine through whatever IV or IO route that is established once we've got vascular access. So the objective of what we're doing here is to evaluate that approach and see if there's any signal there, see if it looks like there's an improvement. So this is really a before and after analysis. It's not a randomized trial. This is continued up until today with this project and protocol change. And we have, for this study, these are kind of the exclusion criteria of what we're going to analyze. So this is adults. We don't have a lot of pediatric patients, but we're going to focus on adults. And there are a few patients who get epinephrine before we arrive there at surgical centers or something like that. We had one recently that was at a outpatient surgical center and was almost completely resuscitated by the time we got there by an anesthesiologist who'd given multiple doses of epinephrine. So obviously we don't include those if the patient already has IV access and they arrest en route to the hospital. Obviously we're just going to go with the IV access. So those are the sort of exclusions. And what I'll present is survival to hospital discharge and some secondary outcomes. The time from arrival to the first dose of epinephrine in these groups, survival to hospital admission. Instead of ROSC, I present survival to hospital admission because of variable rates of intra-arrest transport. So there are cases where a patient remains in PEA, but we transport them so that somebody can, got a high end tidal CO2. It's possible that we got ROSC. We don't know, those sort of patients where we want to look with an ultrasound. So we don't stay in play for every single patient. And this survival to hospital admission accounts for patients who get ROSC either in the field, en route to the hospital, or on ED arrival. And then looking at the most important thing, which is favorable neurologic survival. So this is a very complicated flow sheet, but basically at the bottom, we got 372 patients in this cohort of IM epinephrine. There are a couple of concurrent controls that, even though you protocolize a change, it doesn't always change practice. So patients got IV or IO medication during the period under intervention. We included those in the control cohort. So mostly historical controls with those additional concurrent controls. When you look at the characteristics, one of the big differences that we observed in our database was an increase in the rate of bystander CPR. And I'm not sure if this is real or not, but we'll account for this in our analysis. The reason I'm not sure about this is initially we relied on EMS reports to account for bystander CPR. At around 2016, we started getting all of the dispatch files and actually reviewing them, listening to them, and giving the telecommunicator CPR dispatcher feedback on the approach. And so this may be a data collection artifact because paramedics may not observe the bystander CPR that has occurred prior to their arrival. But nevertheless, there may be a higher rate of bystander CPR in the community, but these are pretty high rates in Salt Lake City. The time was faster. IM route was 4.4 minutes. The median was 4.4 minutes, and IVIO was 7.8 minutes with longer times for IV. It was a couple minutes longer for IV compared to IOs, but this is the median for that entire cohort. So it was faster. When we look at survival to hospital admission, there is the point estimate favors IM epinephrine, but it just barely misses statistical significance on an adjusted basis with a lower confidence interval of 0.99. So even though in the Paramedic 2 trial, we saw the biggest difference was between survival to hospital admission, remember that the control group was getting placebo and in this case, everyone is getting epinephrine. It's just that some people are getting an early dose of the intramuscular epinephrine. What we did see was statistically significant improvements in survival to hospital discharge with a higher odds ratio than the favorable neurologic outcome, but both were statistically significant, and the favorable neurologic outcome just barely so. So this is suggests that the group that got IM epinephrine did better in our cohort, and this is adjusted for things like age, gender, witnessed arrest, bystander CPR, public location, initial cardiac rhythm, EMS response time, all of the standard Utstein variables that need to be controlled for in observational data. So this is, as far as we know, the first clinical evaluation of IM epinephrine. There is an ongoing trial in pediatrics in Canada, and I'm not sure if they have completed enrollment, but my understanding is that is ongoing. Our findings do align with prior reports that suggest that early intramuscular epinephrine does have an effect on ROSC, and that it does have an effect on survival, not only in pigs and rats, but in humans as well. And this also aligns with, frankly, your experience in South Florida with pediatric arrest, that by coordinating the resuscitation so that the child receives an early dose of epinephrine, you saw improvements in survival as well. I think all this is to suggest that we need a randomized trial. This is certainly biased data. I'm not suggesting that this tells us everything we need to know about epinephrine dosing, and there may be a better way to do this. The appeal of this is that 53% of arrests in the Resuscitation Outcomes Consortium data were attended to at first by a BLS provider with a lagging ALS unit. And that's certainly what we have in Salt Lake City. In this study, we put this in the hands of ALS providers. Where I think there's likely to be a bigger impact is where there's a delay to the ALS provider arrival, which adds to that delay to vascular access. So with that, I think I am done. I'd be happy to take any questions or feedback or criticism.
Yeah, well, we have a few questions coming in, and I want to bring a few people in. But what I think it's important for people to understand is the progression with which you're going forward with this information is, number one, the feasibility trial. And so to that question, was that difficult for you to do, to convince anyone at your agency and your community to say, hey, the standard of care is this, but I, Scott Youngquist, want to do this? Was that difficult to get done?
No, what laid the groundwork for this, frankly, was epinephrine is, people recognize that from movies, TV shows, as this important medication. So it's not like a drug with a fancy name that is new that we're putting out there. This is an existing drug that everybody's getting. And it's a route of administration that is something we're also giving. So it was easier than a lot of other interventions might be to get people on board with this. So we discussed it with the IRB, obviously, with the fire department, with community emergency physicians, and some of the community emergency physicians were like, isn't Epi over? I mean, didn't Paramedic 2 trial prove that Epi doesn't work? And so I had to kind of explain, these are the limitations of that study, and here's what we're thinking might work and stuff like that. But, at this point, people are very comfortable with it. And so, yeah, we've been okay with that. But it is one of those things where Paramedic 2 suggested a way forward with epinephrine, and this is one of the ways we considered moving forward with it. Like I said, not the end all be all, but something that may become practical. I mean, you could envision a scenario where trained TSA agents not only use an AED, but while an EMS crew makes their way through the gate at the airport or something like that, they could administer an intramuscular dose of epinephrine and potentially improve outcomes. But really needs a randomized trial.
Yeah, 100%. And so before I bring Dr. Wayne in, you landed on a dose of 5 milligrams. Some people may mistakenly see 5 milligrams and think you're using high dose epi. Can you bust that myth for us? Yeah.
So you might be aware that the dosing of epinephrine is about 10-fold higher in the intramuscular route for anaphylaxis versus an intravenous administration. So if you have a patient with anaphylaxis, right, you're not giving 0.3 milligrams, you're going to give a dilution of that, 10-fold dilution of that. So the dose is based on the animal literature and a linear extrapolation of the anaphylaxis data. So what the pig is seeing is, and this is subject to the rest of our analysis, but when we do this in the laboratory and we compare a dose of intravenous medication at 21.5 minutes, similar to Paramedic 2 versus an early intramuscular dose, they are seeing within about 3 minutes a comparable rise in epinephrine levels, serum epinephrine levels. So this isn't like a massive epi overdose for the patient.
Perfect. Let me bring in Dr. Marvin Wayne. Marv, good morning.
Good morning. Yeah, it is morning here. in the Pacific Northwest. Hey, Scott, that amazing study, amazingly motivated. Three related questions. Question one, you've explained the first one. I wanted everybody to understand why you used the dose that you used. Two, was there any issue with your state boards about BLS giving epinephrine? So that's question two.
No. Question two, no, there wasn't. We approached the Utah State Board of EMS with this pilot project and got approval from the state EMS committee. We had previously applied for BLS dosing of epinephrine for anaphylaxis, meaning BLS dosing from a syringe and vial. You know, we basically have, sort of like Seattle, we've given them a 0.3 ml syringe and a vial to use instead of auto injectors, since auto injectors became so darn expensive. So they had that history. We got approval for ALS provision of intramuscular epinephrine in 2019. And since then, we've gotten approval to put it in the hands of BLS providers. We haven't rolled that out yet, but yeah, that's something that we got approval for at the state level.
So what I think will make it easier for us if we decide to go this way is we already have a mandate in Washington State that every BLS provider has to be able to give epi for anaphylaxis, and we use the vial syringe, the $3 versus the $300 version. And then, kind of related as the last question, I wanted to clarify, because when I connected on, I might have missed it. These are all clearly non-shockable patients, correct? Or are they including shockable?
This includes shockable if the initial defibrillation attempts fail. And we do see, when we break out the subgroups into shockable and non-shockable, there is an association with survival in both groups independently, but we do cut down on the sample size. So those associations are, as I recall, no longer statistically significant because of loss of power. We're talking 341 patients, if I recall correctly. So not a huge number to drill down into. I will say that it looks like the greatest effect is in patients who go on to get intravenous medications, which makes sense that there's a longer lag, obviously, between that and an IO dose. And so I think in an IO heavy environment, the effects of an early IM dose will be diminished. Although, you know, I didn't mention, I think that IO is associated with worse survival than IV in these epidemiologic studies as well. And even humeral IO in one recent study was as bad as tibial IO for ROSC and survival compared to intravenous. So intravenous is certainly the gold standard. And I think if you get rapid intravenous access, then that's the gold standard. That's what we should do. It's just not feasible for a large chunk of our cardiac arrest population because of the difficulty of getting the access, the lack of a skilled provider on scene immediately, and stuff like that.
Yeah, thank you. Just a side comment. For reasons I don't understand why giving this works so well in the VF patients, about 40 years ago, we actually drew levels of the catechols, all of them, presented but never published, which is unfortunate, and found the initial epi in a VF patient was sky high, and yet we give more, and yet it works. So there's a lot of yet to learn, as I said, but thank you for bringing this to everybody. And it's a great idea. And since we already have BLS providers carrying the epi, it's something I have to give strong thought to.
And,
yeah, in the pig there where we induce ventricular fibrillation, and so it's an observed arrest, and we let it sit there in VF for 7 minutes. When we start CPR and draw levels, there is a surge in catecholamines that is actually higher than subsequent intravenous doses, but that disappears in most animals within a couple of minutes. So there's a window very early where you probably don't need epinephrine for the VF patient. We're just unable to intervene on a lot of patients. Now, those are the one shock wonders, sort of thing, or the ones that, you shock twice and they're back, and by the time EMS arrives because the defibrillator was on scene or something like that.
Scott, I actually wanted to kind of ask about that same exact question. In my protocols for years now, we've removed epi altogether from the shockable rhythms. Were you able to separate out that data in your study? There's a big meta-analysis that was published in August of 2023 showing that epi has no benefit in shockable rhythms. And I'm wondering what your thoughts are on that aspect.
Yeah, in our data, there is a positive association between the early IM dose and all these outcomes I mentioned. But
irrespective of the rhythm.
Yeah,
Meaning both
shockable and non-shockable. And I have a cohort though that has IM epinephrine followed by ROSC before the ability to achieve vascular access. And that is a group that I don't know what to do with. So you could say, well, those patients didn't need epinephrine. They fell out and they just happened to get it right before return of spontaneous circulation. And so the IM epinephrine was unnecessary in that cohort. It's possible that in that cohort are people who were saved from further doses of IV or IO epinephrine. We just don't know. So when I look at the analysis and I say, let's exclude those IM epi only patients and look within groups of IV or IO, we haven't looked at the rhythm, but we've basically seen the biggest effect is in the intravenous group in terms of augmenting survival. And that's probably because of the longer delay to intravenous medication than IO.
I think physiologically also, when you give the IM epi, you're not getting that big burst of epi through an IV. I think the 1 milligram, there are people who are debating whether the 1 milligram is the right dose, right? There are people giving half milligram every 5 minutes, half milligram every 10 minutes. And so perhaps the pharmacokinetics of giving epi-IM could kind of give enough diastolic boost, if you will, to get the coronaries reperfused without doing too much negative damage there. So we have other people. I don't want to hog the mic here, but Josh Kimbrell, do you have any? Did you have preloaded syringes, or did crews have to draw out of vials? That's his question.
These are drawn up in a vial. So if you
a 30 cc vial is what you're giving them.
Exactly. Okay. Yeah. So if you preload syringes, your epi actually gets degraded pretty fast. So if you talk to pharmacologists, they will say do not pre-draw it into those syringes because by the time you grab it, it's going to be less effective than if it comes in the vial, which is sterilized and covered somewhat and stuff like that. So
excellent. Eric Chase asks, how is VF induced in animals compared to etiology factors of cardiac arrest in human patients, asphyxia, coronary artery disease, etc.? Is data available to see where the best ROSC is happening with IM versus IV versus IO?
For the pig model of cardiac arrest is, I would say, the minority. You're basically showing your model is a minority of cardiac arrest. So how we induce it is we put a bipolar pacing catheter in contact with the right ventricle, and then we attach it to a 9-volt battery, and that puts the pig into ventricular fibrillation. There are other methods in the rat and mice models that use potassium. Occasionally, an acute coronary occlusion is performed to do the VF model, but then often you have to stimulate the heart as well because they don't all go into ventricular fibrillation. So there is no model of cardiac arrest in the animal that has really good verisimilitude to human cardiac arrest for sure. But it's a starting point, and it's definitely a hypothesis generating model, and not something we should take to the bank.
So Scott, we're coming up to the end here. Amazing presentation. I'm gonna ask an important question here, because I know there's a lot of people on this call. By the way, this is the highest number of people I've ever had on a webinar. So figured it would be you to do that. Thank you so much. My question for you is this. You've clearly been doing this for years. You didn't show clinical equipoise. You actually showed that this could be better. Could be better. No RCT, but it could be better. Mm-hmm. What prevents people in states like Florida and states like Texas, where it's delegated practice, to put this in before the RCT? What do you say about that?
really, there's, it's only local regulations that prevent this from being tried, and other things from being tried. So, I would say it's something that may go the way of the dodo. And if you look at the history of resuscitation science, most of it does. So, the downside to adopting something like this is we're developing a randomized trial to study it better than we have so far, and it could upend what we've seen so far. It could result in a complete reversal of the findings here. So that's the caution. It looks good. It doesn't look bad, but we can't say it works at all based on the existing data. We really need a randomized trial.
So are you comfortable saying that it doesn't cause harm? Or not yet?
I am not yet. I'm
Okay.
mostly comfortable, but it happens sometimes that something that looks good in a setting like this, when randomized and with a blinded placebo, actually looks worse than the standard of care. So I want to be cautious about it, but it's looking good so far.
And then to that point, then the RCT, can you kind of is it your group who's going to be leading this, number one? And if so, what is the timeline on that? Because I know those, an RCT, as people know in EMS, that's heavy duty stuff, my friend. I mean, so what are we looking at timing wise? Couple years?
Yeah, at least a couple years. The trial itself would probably be a 3-year trial if funded and approved. We've been working on the design for a couple of years now, and we presented to the Siren EMS working group to get some feedback. There are a lot of issues to think about. So do you make this an ALS only trial? Do you only include adults, or do you include adults and pediatrics? What is the outcome for epinephrine that is a reasonable expectation? Is it an epinephrine trial? Should it be 72-hour survival? Should we shoot for neurologically intact survival, knowing that will be a smaller effect size than any survival to hospital admission or 3-day survival? So all of that plays into the sample size. And do you make it an ALS only drug? Do you make it a BLS treatment? Those sort of things we're hotly debating and trying to design around. So if one of you can do this trial faster than I can, please do so, and I can move on with my life in one way or another.
We don't have the brain power that you do, but I would vote to make it BLS. I would vote to 100% add the kids in there, because it would be really, I mean, those, if you think about it, are the hardest for people to get things moving on, to get the epi on, to do the right thing, to stay on scene. So if I was at the table, I would definitely, we'd have a vote for that as well. So, but Scott, thank you so much for this great presentation. We had people staying on till the very end. There's a link in the chat for people to move over and join Dr. Pepe's webinar. He's going to have Doug Wolfberg on as one of his guests today. But Scott, thank you so much. Take us away with some final thoughts. I'll give you the last word. And again, thanks for joining the Florida EMS webinar.
Peter,
there's Paul.
No CME.
Hey, Paul.
You could get the names of people that were on if there's some way to record that so we can get them the information later. They're trying to get it and create those CMEs for 2024 today. Number two, I agree with everything Scott said. And I wouldn't even bother with an RCT. I'll talk to you about it later on. And I have a suggestion for you, Scott, to bypass doing all that stuff you don't have to do. And that will just confound things. You're on the right track. You're doing exactly the right thing. And give me a call sometime. Okay? Thanks. I got to go. And you're welcome to get on, Scott. I will. All right. Thanks. Bye-bye.
Thanks, Paul. Appreciate it. So Scott, take us away with some final comments. And again, thanks for joining us today.
Okay. Well, I'll just say that what you're doing today can probably be improved on by just thinking about strategies for early first dose administration of epinephrine without even intramuscular. There are probably improvements to be had in the dosing of this earlier. That's why a pit crew approach is very useful in having enough hands on scene so that the person administering medications isn't distracted by other tasks. They're not managing the airway and then going to do medications. get enough people on scene so that somebody's dedicated to that task, and they know immediately once epi is indicated, boom, we're giving it. It's after the second shock, or as soon as you analyze the rhythm and see it's non-shockable, boom, get that epinephrine in there. And I would work for intravenous vascular access, even if you have an IO, just to because of the disparity in survival between IV and IO.
Beautifully said. All right, excellent. Well, thanks everybody. Great session. I appreciate everyone joining. It'll be on our YouTube channel. Hopefully we'll see everyone at NAMSP in Austin next week. Scott, you're going to be there?
I will be there, so hope to see a lot of you there.
Awesome. We'll see you then. All right, everyone. I'm going to stick around until you guys click the link or you exit the Zoom. Appreciate you guys coming on today.